The characteristic polynomial of the 4 by 4 matrix which is appearing on the screen there is lambda to the power 4 minus 14 lambda cubed plus 69 lambda squared minus 144 lambda plus 108. In this tutorial, I'm going to find the eigenvalues of the matrix A. In this case, we are already given the characteristic polynomial Pn of lambda there. By definition, we know that eigenvalues are roots of the characteristic polynomial. So since the characteristic polynomial is given there, what we have to do is we have to set Pn of lambda equals to 0 and solve for the equation for lambda to get the eigenvalues. So in this case, when you set Pn of lambda equals to 0, we would have lambda to the power 4 minus 14 lambda cubed plus 69 lambda squared minus 144 lambda plus 108 is equals to 0. We now have that equation. What we can do is we can try to find factors by trial and error. So we can start by lambda equals to 1. If we substitute lambda equals to 1 into that equation, we will have 1 minus 14 plus 69 minus 144 plus 108, which will give us a 20. Because we are putting 1 wherever we have the lambda there, and we would have 20 is equals to 0, which is not valid there. So lambda minus 1 is not a factor. We can try lambda equals to 2. If we substitute lambda equals to 2 into that equation, we would have 16 minus 112 plus 276 minus 288 plus 108, which will give us a 0, and we would have a 0 equals to 0, which is true. So what we would have there is lambda minus 2 is a factor of lambda to the power 4 minus 14 lambda cubed plus 69 lambda squared minus 144 lambda plus 108. To get the other factors, we would have to use a long division. So I'll write the lambda minus 2, the factor that we have just found, and under the division sign we have the lambda to the power 4 there. Lambda to the power 4 minus 14 lambda cubed plus 69 lambda squared minus 144 lambda plus 108. The leading term there is a lambda to the power 4. We divide it by the leading term of the factor that we've just found, the lambda minus 2. The leading term is a lambda. So it will be lambda to the power 4 divided by lambda, which will give us a lambda to the power 3. So I write it on top there. Multiply the lambda to the power 3 by lambda minus 2, and we get lambda to the power 4 minus 2 lambda cubed. Subtract that from the one above, we get lambda to the power 4 minus lambda to the power 4, it gives us a 0. Minus 14 lambda cubed minus 2 lambda cubed to give us a minus 12 lambda cubed. And then we'll write the others as they are there. So we'd have minus 12 lambda cubed plus 69 lambda squared minus 144 lambda plus 108. The leading term now there is a minus 12 lambda cubed. We divide it by the lambda and we get minus 12 lambda squared. So I write on top there minus 12 lambda squared. Multiply the minus 12 lambda squared by lambda minus 2, and we get minus 12 lambda cubed plus 24 lambda squared. Subtract that from above, and we have minus 12 lambda cubed minus 12 lambda cubed gives us a 0. 69 lambda squared minus 24 lambda squared, and it will give us a 45 lambda squared. Then we write the others as they are, minus 144 lambda plus 108. The leading term now there is 45 lambda squared. We divide it by lambda and we get 45 lambda. So it's a positive one, so it's plus 45 lambda. Multiply the 45 lambda by lambda minus 2 and we get 45 lambda squared minus 90 lambda. Subtract it from the above there, we get 45 lambda squared minus 45 lambda squared to give us a 0, minus 144 lambda minus 90 lambda minus 144 lambda minus 90 lambda, it gives us minus 54 lambda. Then we have that 108 there at the end. Our leading term now is a minus 54 lambda. We divide it by lambda and we get a 54, a minus 54. So I'll write the minus 54 there. Then multiply the minus 54 by lambda minus 2 and we get minus 54 lambda plus 108. And when you subtract those from above, we get a 0. So what we have found there is the other factor of lambda, the power of 4 minus 14 lambda cubed plus 69 lambda squared minus 144 lambda plus 108. And that factor would have lambda cubed minus 12 lambda squared plus 45 lambda minus 54. Therefore, our equation becomes lambda minus 2 multiplied by lambda cubed minus 12 lambda squared plus 45 lambda minus 54 is equals to 0. We now go on and look at this part here where we have that cubic there, lambda cubed minus 12 lambda squared plus 45 lambda minus 54. And we try to find factors by trial and error. And in this case, we'll get lambda minus 3 is a factor of lambda cubed minus 12 lambda squared plus 45 lambda minus 54. To get the other factor, we would have to use a long division. So in this case, we are now using the factor that we have just found, which we are saying is lambda minus 3. So we'll be having lambda minus 3. And then under the division sign there, we would have our lambda cubed minus 12 lambda squared plus 45 lambda minus 54. The leading term there is the lambda cubed. We divide it by a lambda and get lambda squared. So I'll write a lambda squared on top there, multiply the lambda squared by lambda minus 3, and we have lambda cubed minus 3 lambda squared. Subtract that from the one which is above, we would have lambda cubed minus lambda cubed, it gives us a 0. Minus 12 lambda squared minus 3 lambda squared, it gives us a minus 9 lambda squared. Then write the other terms as they are, plus 45 lambda minus 54. The leading term there is minus 9 lambda squared and divided by lambda, we get minus 9 lambda. So I'll write on top there minus 9 lambda. Multiply that minus 9 lambda by lambda minus 3 and we get minus 9 lambda squared plus 27 lambda. Subtract it from the above, we get minus 9 lambda squared minus 9 lambda squared, it gives us a 0. 45 lambda minus 25 lambda, it gives us 18 lambda. Then write the minus 54 as it is there. The leading term now is an 18 lambda. We divide it by lambda and we get an 18. So I'll write plus 18 there. Multiply the 18 by lambda minus 3 and we'll get 18 lambda minus 54. And when you subtract, we would have a 0. So we would have found the other factor there. So what you are saying is lambda cubed minus 12 lambda squared plus 45 lambda minus 54 is factors lambda minus 3 and the one which you have just found them, lambda squared minus 9 lambda plus 18. So our equation will become lambda minus 2 multiplied by lambda minus 3 multiplied by lambda squared minus 9 lambda plus 18 is equal to 0. So for the equation that we are having now, if we look at this part there, that's a quadratic lambda squared minus 9 lambda plus 18. We can try to find factors, two numbers, which when you multiply them, they give us an 18. When we add them, they give us a minus 9. Those two numbers are minus 3 and minus 6. So what we'll be having there is it will be factorized to lambda minus 3 multiplied by lambda minus 6. So our equation becomes lambda minus 2 multiplied by lambda minus 3 multiplied by lambda minus 3 multiplied by lambda minus 6. Now from this equation where we have found the factors, we can now solve for lambda and we will see that our lambda there, and the first one is lambda 1 is equal to 2. For the second one, we would have lambda 2 is equal to 3. But in that equation that is highlighted, we have lambda minus 3 multiplied by lambda minus 3. That means lambda equals to 3 is a repeated root. It's appearing as a root of the characteristic polynomial 2 times. So we'll say that lambda 2 there, which is equal to 3, is algebraic multiplicity 2, because it is appearing as a root 2 times. And the other eigenvalue, the last one, lambda 3, is equal to 6. So those are the eigenvalues of the 4 by 4 matrix that we were given.